problem, and what are the essential data which is needed for completing this particular problem. So the investor has purchased the bond with a 15% of return, and the face value of the bond it is 500 rupee, and the market price is 400 rupee. So these four information along with the years of maturity is given in the problem. So I have mentioned mentioning the face value, market price, and years to maturity. That value is available here. 0.15, the 15%. The face value of the instrument it is 500, and the market price is 400, and the number of years is 5 years to maturity. So these information available in the problem. Okay. So what is the formula for calculating yield to maturity? Or the yield to maturity is calculated on the basis of market price. Market price is equal to the value of C divided by 1 plus YTM to the power T plus PV divided by 1 plus YTM to the power N. Here you can use the summation of sum of the value you can take. Okay. So here you need to understand what is MP is a market price, C is a constant payment, C is a coupon payment, C we call it as a interest payment. So in the particular problem, the interest payment, what is the interest payment? The interest rate is 15%. So R multiplied FV, you can get the CP, coupon payment. So here the 15% is calculated from the face value of the instrument. Always the interest is calculated on the face value of the instrument. So the 75 rupee is a coupon payment. Rate is 15%. The coupon payment is 75 rupees. So here the C is 75 rupees. Coupon payment is 75 rupees. What we call it as interest payment is 75 rupees on this particular problem. And here you can take a TV. What exactly a TV? TV is a terminal value or maturity value or call price. We call it as a call price. If it is like yield to call, it is a call price. Okay. Or the maturity value or maturity value. You can take it as T. And here we can use the to the power T up to the term. Here we are using number of years. Both are same. Here we are using for 5 years. So any clarification on this part for defining of variable? So what exactly the YTM? Yield to maturity is calculating the percentage or the rate of return which is equal to the market price. So whatever the market price, it is going to understand or it is going to be calculated the market price, the value of market price which is equal to the present value of cash flows. Calculating the present value of cash flows. It is whatever the value I will receive during the maturity period, whatever the interest payment I will receive during the period, all the values are converted to the present value. So what percentage I can exactly the income received or income generated from instrument or the total value of investment is equal to the market value. Total value of investment is equal to the market value. I'm going to find it out the percentage. We call it as YTM. So yield to maturity. So yield to maturity. Okay. So for how I can do yield to maturity, prior to that, there are two different. So hope you know the maturity price and whatever the payment will be received, whatever the income will be generated out of the instrument can be converted into the present value because the interest will be received in future. Terminal value will be get at the end of the period. But you need to understand the sequence of payment, sequence of payment, what I will receive, sequence of income, what I will receive. If you can take a interest, interest will be received on periodical basis. Periodical basis. Interest will be received on periodical basis. But you can take the maturity value or maturity benefit will be received at once. Received at once. So why I'm saying that what type of calculation or what type of formula can be used for this purpose? You need to know that for the reason I just have mentioned here, interest is calculated on periodical basis. Whereas the maturity benefit, I get maturity benefit at least once during the investment I can get. Okay. So here, why I'm saying that for the calculation of present value, the present value annuity factor is used for interest calculation. Present value interest factor is used for maturity value calculation. Because for the maturity value, I can apply to get what exactly the present value of interest factor. It is calculated 1 divided by 1 plus r to the power n. Hope you all already remember the present value of interest factor calculation. Okay. While I am calculating the present value of annuity factor, the present value of annuity is calculated 1 divided by r multiplied 1 minus 1 divided by 1 plus r to the power n. So the formula can be applied to get the annuity amount. What is annuity? Oh, you know that I can take a 5 years. This is a year 1, year 2, year 3, 4 and 5. These are the 5 years. These are the number of terms, number of years in this particular maturity. So here, I'm in what year? It means I can say if I'm going to make investment, the current market price, it is I'm in 0th year. The present value, what we call it as 0th year. Present value, what we call it as 0th year. In the first year, if I can take the coupon payment or I can take the interest will be received in the first year, 75 rupees interest will be received. Second year, 75 rupees interest will be received. Third year, 75 rupees interest will be received. Fourth year, 75 rupees interest will be received. Fifth year, 75 rupees interest will be received. So this is the payment what you will receive in another 5 years. You can take, while you can take the terminal value, you can get the maturity benefit at the end of the year. What is the maturity benefit you will receive at the end of the year? What is the terminal value you will receive at the end of the year? Normally, you can make the deposit of 5,000 rupees. So the interest of 500 is given. So along with 5,500 is given. It means the 5,000 what you have invested, the same is given as a terminal value. The same is given as a maturity benefit. So here the face value, we can take it as a terminal value is 500 rupees. Terminal value is 500 rupees for this particular problem. So any clarification, wherever you have a problem or not able to understand, you just raise the query or ask the question. Okay. So this is about the situation you need to understand. So we are in present. 1 year after I will receive 75 rupees. After 5 years, I will receive 500 rupee terminal value along with the accumulated interest. Along with the interest I will receive. So what maturity benefit I will receive? Interest payment plus terminal value or the value of investment I will receive. So here together the value will be received. But what we are doing, all the values are converted into the present cash flow. All the values are converted into the present cash flow. Okay. So I can say here I can take if YTM is equal to 20%, if YTM is equal to 20%, I can take from the trial and error method. So I just have calculated the present value interest factor. The present value interest factor. For the first year, what is the present value interest factor? If I'm not applying the annuity factor, if it is like a present value interest factor, what would be the value I will receive? 1 divided by 1 plus 0.2 to the power 1. It means 1 divided by 1.2. It is 1 divided by 1.2. It is for the first year. For the second year, it is 1 divided by 1.2 to the power 2. This is for the second year. This is for the second year. For the third year, you can take 1 divided by 1.2 to the power 3. When going for year on year, then only you can know that how we can use the formula directly for annuity calculation. Okay. This is for third year. This is for 1.1 divided by 1.2 to the power 4. Next one, 1 divided by 1.2 to the power 5. So these are the present value interest factor. So what I can do, I will multiply the present value interest factor with the coupon payment. With the coupon payment, I can get the present value of interest. Present value of interest. Simply multiplying with. So the 75 rupees will be received in 1 year later is equal to the present value of 62.5 rupees. Similar to the second year, third year, fourth year. So what is the total value of present value of, or what we can say, the present value of coupon payment, cumulative coupon payment. What is cumulative coupon payment? I will say. So I just sum of all the factors, sum of all the present value of coupon payment. Together, the total value is present value of coupon payment is 224.29559, or you can take 224.3. Is what you can take it as. The present value of coupon payment. So this is one thing. Plus, you can take what is the value of the mature terminal value. Terminal value is 500 rupees. And what is the overall price? You can take it is 724 rupees. It becomes 724 rupees. Okay. But what you can take here, you need to understand that. So here you need to calculate. This is for the fifth year. You can convert this into the present value. So this is the fifth year. You need to convert the present value interest factor. For the fifth year, you need to calculate. So the fifth year, it is already available. 0.4018 multiplied with the terminal value, you can get 200.9388. It means 200.94 is a value. So together, what you have, the value it comes, together you can take, it is 425, but you need to calculate the value. It should be one value should be upper value, another value should be a lower value for the calculation. But here what I did the interest factor calculation. It is a lengthy process. I just have followed here. In spite of that, I have a shortcut method for calculating this. In spite of that, I can use the shortcut method. What is the shortcut method for calculating present value annuity factor? It is 1 divided by r multiplied 1 minus 1 divided by 1 plus r to the power n. First, what I will calculate, for the 5 years, I am going for the calculation. For the 5 years, it means you can take 1 divided by 1 plus 0.2, it means 1.2 to the power 5. I need to calculate. The same result only I will receive here. is equal to, so this is a present value interest factor 1 divided by 1 plus r to the power n. After this result, you can get the residual value 1 minus 0.401878, 0.598 is a residual value. Along with this, along with the value, you can take 1 divided by r. It is 1 divided by 0.20, 1 divided by 0.20 multiplied with 1 minus 1 divided by 1 plus r to the power n. You may get the same value. You may get the same value. You just have to multiply this value. So here once again, I'll just check with this value. This is for the 20%. What we did the calculation. So the calculation which yielded 1 divided by 1 plus r. Here 1 plus r is a 20%. It can be written as 0.20. Hence 1.2 to the power 5. 1.2 to the power 5. It is calculated, and 1 minus. Here I can take 1 minus the value. You can get the residual value of 0.59, and with that the value. What I can do, it is 1 divided by r multiplied. What is 1 divided by r? You can take 1 divided by r is 1 divided by 0.2. It is multiplication factor of 5. It is multiplication factor of 5 is multiplied with 0.59. You can get 2.99. 2.99612. 2.99612 is a value. So this value is multiplied with the coupon payment. What is the coupon payment? Here the 75 rupees is a coupon payment because the coupon rate is 15% and the face value of the debenture is 500 rupees. Hence the 75 rupees is what the value. You can check the value. Here 224.295, the same value you have received here. Here also the present value annuity factor, the same value interest factor. For the cumulative value you have calculated with the same result. While applying the formula, you can get the same value. This is only for simplification process. I'll just make it as the green color. It may be the alternative solution can be used for this particular purpose. Okay. So the terminal value, everything remains constant. When applying YTM is equal to 20%, the result is 425.14. I just go ahead with the other percentage. I can go with the previous problem we have worked out with 25%. I'm just not going with the 25%. I can take it as a 30%. YTM is equal to 30%. In case if the interest is equal to 30%, if the interest is equal to 30%, we can take it as an interest. R is equal to 30%. Then it is easy for you to calculate. R is equal to 30%. When R is equal to 30%, I can apply the formula directly, not going with the step-by-step method. If I can calculate the present value annuity factor for 30% for the period of 5 years. Hence, it is 20. It is the 30%. It means 1 divided by 1 plus 0.30 to the power 5. It means 1 divided by 1.3 to the power 5. 1 divided by 1.3 to the power 5. So in that the value you can subtract or get the residual value of this. This is the residual value. With the residual value, I can calculate 1 divided by R. R is here. The rate of interest is given here as 30%, can be written as 0.3, it comes 3.33. So this value 1 divided by r is multiplied with 1 minus 1 divided by 1 plus r to the power n. So here the present value annuity factor for 30 percentage for the period of 5 years is 2.43557 is a value. So this value is being multiplied with the interest payment. The interest payment, which remains constant, is a 15 percentage of face value. It comes 75 rupees. So the 75 rupees is multiplied. You can get 182.667, means 182.67 rupees is what we call it as. This value we call it as cumulative present value of coupon payment. Cumulative present value of coupon payment is calculated. Along with this, you can calculate present value of interest factor for 30 percentage for the period of 5 years. So the same value only I am going to receive. Means 1 divided by 1 plus r to the power n. It means 1 divided by 1 plus r to the power n means it is 1 divided by 1.3 to the power 5. Here the 5 years it becomes 2.0.269 is a interest factor. This interest factor is being multiplied with the face value. The face value of the instrument or the terminal value of the instrument is 500 rupees. Hence, this 500 multiplied with the present value of interest factor, it is 134.6645. So what is the value? What is the value of the total value? The total value, it comes 300, and total maturity benefit, it comes, if the rate of interest is 30 percentage, it comes 317.33. Okay, so r is equal to 30 percentage, it comes 317. R is equal to 20, you can get 425. So you can get one lower value and one higher value. So hope you know there are two different testing methods, two different trials are taken, where I can understand that what exactly the WTM can be calculated. The WTM is calculated on the basis of all the present value of cash flows, cash inflows are equal to the market price. So the market price is 400. So we are adjusting the values. We are adjusting the rate of interest towards the market price. So exactly it is equal to the market price. So here you need to calculate. So what are the formula you have applied? First, you have applied the formula for market price. Second, you have applied the formula for present value annuity factor. Third, you have applied the formula for the present value interest factor. Fourth one, you need to apply the formula, IRR formula can be used to understand what exactly the WTM, what exactly the yield to maturity for this particular calculation. So here the exact WTM it can be calculated by using the IRR method. First, I need to find out the lower rate of return plus present value of lower rate minus market price divided by present value of lower rate minus present value of higher rate multiplied with the difference of higher rate minus lower rate. Understand the formula at first. I have a formula. I just take the formula here. Okay. So the same, I have a formula. In this formula, you can understand that the lower rate and present value of lower rate minus market price divided by present value of lower rate minus present value of higher rate multiplied with the difference of rates, higher rate minus lower rate. So here, what is lower rate, what is higher rate, what is the present value? You need to calculate this. So here, you need to identify from the calculated values. You can take the rates at first. What are the rates? The R is calculated. There are two different values or two different rate of interest is calculated. While I have calculated a 20 percentage, present value from the instrument, it becomes 425.24. And if I have taken the 30 percentage, if I have taken the 30 percentage, the present value of the payment, it comes 317.33. So these two values I can take. And one more value, I need a face value of the instrument, sorry, market price of the instrument. Market price of the instrument, it becomes 400 rupees. It was 400 rupees. It was calculated as 400 rupees for this particular problem. And here you can calculate what exactly the values are making the difference, values which are making the difference over there. Okay, so here you can take what is the lower value, what is the lower rate, what is the higher rate. Here you can take the lower rate is 20%. You know that is a 20%, and the higher rate it I have calculated is a 30%, and the market price it is given in the problem for 400 rupees. And the present value of lower rate, it is given in the problem what we have worked out. The value it comes, it means the present value of interest payment plus present value of terminal value or the maturity benefit is equal to, it is together, it is equal to 425.14. 425.14. The present value of higher rate, the present value of higher rate for this particular problem is being given. It is like 317.33 is the present value of higher factor. What is the difference between the higher rate minus lower rate? It means 30% minus 20% is a 10% is a value. So you know that here it is, you have calculated the values. The values are it comes like the 10% is a difference, and the rates are available. You can just substitute the values. So what exactly here the lower rate is 20% plus present value of lower rate minus market price. The present value of lower rate is 425 minus market price. It is market price is 400 divided by the present value of lower rate. It is 425 minus present value of higher rate. It is 317.33. Multiply with this value. You can multiply it with higher rate minus lower rate is a 10. It's a 10. So here I can take 20 plus, you can divide 25.24 divided by 107.8 and multiply this value with 10. Multiply this value with 10. Again, I am going for a third step for the calculation. This is being multiplied with 10. And these two values can be added together. It means 20 plus 22.34 is what? 24.234 is what the WTM, yield to maturity for this given problem. 22.34 is a yield to maturity for this problem. Any clarification? Any clarification on this? Hope you understand the problem and what are the formula can be used for this purpose. The same problem we have worked out in the last class. Again, why I am writing the same for the understanding purpose, I will take the one more problem on this particular yield to maturity for your better understanding. And what is the purpose in which I need to calculate this? Whether the served purpose can be fulfilled or not. This is my question. Whether the served purpose can be fulfilled or not. You can check. You can check the value 22.34. I'll just change the color. Uh, 22.34. You can take it as a YTM and do the calculation whether the 400 is equal to 400 or not. You can check it out. This is only for trial purpose. I'm just talking only for the trial purpose. You can do it. Hope you understand what I'm trying to say. In that, whatever the income you have received, say for example, The previous problem we have worked out the present value annuity factor, and the present value interest factor is calculated for the terminal value. Present value annuity factor is calculated for interest factor or interest payment. So here you can take if the interest rate is, if I have calculated 1 divided by, or here is 0.2234. It is 22.34 is or in this particular problem. It is multiplied with the 1 minus 1 divided by 1 plus r is 0.2234 to the power 5 to the power 5 to the power 5 is 1 minus 1 divided by 1 plus r to the power n. So the value, the present value annuity factor is 2.84 or 2944. So this present value annuity factor is multiplied with the coupon payment. The coupon payment is 75 rupees. It's the interest rate. So the interest rate, it becomes interest payment. The present value of coupon payment, it becomes annuity payment is becomes 213 rupees, 213.22 rupees. 13.22 rupees. So just only for the validation purpose, I am doing this. Present value interest factor for the terminal value, it is calculated 1 divided by 1 plus r here is 0.2234 to the power 5. To the power 5, it is calculated. You can get the present value factor is the 0.346488. So this value is multiplied with the face value, or we call it as a terminal value in this particular problem. It becomes the present value of terminal, or we call it as maturity value, present value of maturity benefits or maturity value. It comes 182. You can add this two values. You can get 395.66. It is what closely, approximately, it is related to 400. It is not exactly, it means that 399 rupees. It is approximately equal to the value. Approximately, which is equal to the value, it comes. So this is only for the verification purpose only I am doing this. Okay. Hope you understand this particular problem, what we have taken, the yield to maturity, or the calculation of yield to maturity. Okay. One more, the problem that I have taken here, I just change the value. In this problem, you just work it out this problem. I just change the values alone. Investor purchase, you can take 18%. You can take the face value, it is 1000 rupees. And you can take the market price of the instrument. It comes 900 rupees. Will be repaid on 10 years, 10th year. Repaid on 10th year. So you, after this, we'll move on to the next problem. Next calculation. So you can complete it as quick as possible. You can complete this. First, wherever you are approaching the problem, you can derive the variables out of that, and remember the calculation. You need to work it out. So if it is in the yield to maturity, you need to calculate the first. What you need to calculate? You need to calculate with the different trial and error. Need to be calculated with a different interest rate. Whether using the different interest rate, when exactly the market price, which is equal to the present value of coupon payment plus terminal value. It is together, which is equal, the percentage is called it as yield to maturity. So here the 18 percentage you can take, coupon rate is 18 percentage, it is 0.18. And you can take here the face value of the instrument is given as 1000 rupees. The market price is given, market price of the instrument is given as 900 rupees. The years to maturity is 10 years to the maturity. So these are the four variables. Four variables are available in the problem. Make it fast. Any of you have calculated with the percentages, any percentage, like you can take 10% or 15%. You can take. Optimally, you can take 15%. In a problem, you can optimally take 15%, or optimally you can take 20%. To understand that, if there is a kind of a huge deviation between the face value and you can take the market price, for the huge difference, you can take the higher value. If it is not like a huge difference, you can go ahead with the lower value. The first trial, I'll just work it out with 20%. 20%. So what is the formula can be applied, can be used for this particular purpose? It is C divided by 1 plus yield to maturity to the power. Here in the problem, the T is 10. It is added together with the terminal value divided by 1 plus yield to maturity to the power 10. To maturity to the power 10. So in the problem, I just work it out this particular problem. So this particular coupon payment you can take. Before that, you need to calculate the coupon payment, because it is not yet calculated. Only the coupon rate is available for the problem. The coupon rate is 18%. Can be calculated from the face value of the instrument. It becomes 180 rupees. 180 rupees. 180 rupees. You can take 180 rupees. Okay, what becomes, let's see. And here I'm going to calculate. Here I'm going to do the calculation. First, I need to identify the present value of annuity factor for the 20%. Here I have calculated 20% for the period of 10 years. I need to calculate. So here, how I can do the calculation? First, you need to calculate 1 divided by R. 1 divided by R is 1 divided by 0.2 is 1 divided by R. And you can find it out. 1 minus 1 divided by 1 plus R to the power n. Here, 1 minus 1 divided by 1 plus R is 0.2 to the power 10. To the power 10. It's 0.83. So this 0.83 is multiplied with the 1 divided by R. You can get present value of annuity factor. Present value of annuity factor is 4.19. Present value of annuity factor for 20 years. 20% for the period of 10 years, it becomes 4.19. And this value is multiplied with the coupon payment. The coupon payment for the problem, it is given as 180 rupees. It is 180 rupees. Hence, the present value of coupon payment for the problem, it is given, it is 754.645 rupees. 645 rupees. So this is I have calculated for the coupon payment. Next one I need to calculate for the terminal value. For the terminal value, present value interest factor for 20% for the period of 10 years need to calculate. For the period of 10 years need to calculate. This is an interest factor. It means one time occurrence may happen. It means 1 divided by 1 plus r to the power n. You can use the formula to get it is 1 divided by 1 plus or here is 0.2, it means 20% to the power 10. You can get 0.1615 is a present value interest factor. So this present value interest factor is multiplied with the terminal value or the face value of the instrument, it is 1000 rupees. Hence, the 161 rupee is 161 rupees was the terminal value, and this value along with the interest payment together it comes the present value of coupon payment plus maturity benefit, it becomes 916 rupees. 916 rupees. So here what you can do at the rate of 20%, you can take at the rate of 20%. It is more than, it is slightly more than the market price, slightly more than the market price. So I need to get one more value which is slightly less than the market price. When it is less than the market price, when you can get the value which is less than the market price, whenever there is increase in the rate of interest, you can get the lower value. You can get the lower value. So what I can decide after the 20%, I can go for 25%. Can go for 25%. So you can also work it out for the same. You can also apply the 25% to get the result. For the 25% for the same type of calculation I'm going for. Same type of calculation I'm going for. Here also I'm going for the same, but what I can do, I just change the value alone. Here the present value annuity factor for the interest payment, the calculation is being done for 25% for the period of 10 years. And here the 25%, it means 1 divided by r is 0.25, it becomes 4. And 1 minus 1 divided by 1 plus r to the power n. Here the rate of return or the rate of interest we have taken as 25%, it is 0.25. Hence, in the problem, 1 minus 1 divided by 1 plus r is 25% to the power 10. So we have the factor value of 0.89266, and this value is multiplied with 1 divided by r. It becomes the present value annuity factor for the problem is 3.570, and the present value of all together with the interest factor, it comes 642.69. And you can take here the present value is calculated for the terminal value or the terminal benefit. It becomes 25% for the 10 years. And this is also being calculated for 25%. It means 1 divided by 1 plus r. Here 1 divided by 1 plus 25. It means 0.25 to the power 1. It becomes 0.13107374. Hence the terminal value, the present value of terminal value becomes 107.34. 107.34. It is the present value factor is multiplied with the face value of 1000 rupees. It becomes 107.37. And the total value, the summation of present value of coupon payment along with the present value of the terminal value together, it comes 750 rupees. It is less than the market price. So one value we have above the market price, one value I have below the market price. So these are the two values what I have calculated. Then I need to calculate the yield to maturity. The yield to maturity here it is calculated by using the formula. What I have lower rate plus present value of lower rate minus market price divided by present value of lower rate minus present value of higher rate multiplied with this value. This value is uh, multiplied with the difference of higher rate minus lower rate. Higher rate minus lower rate is a formula. Can be applied for this particular purpose. So here, the one more thing that you need to understand, what exactly that you need to understand here, the higher rate minus lower rate, we need to define the variable at first. So what is lower rate? What is higher rate? What is higher rate? And what is higher rate minus lower rate? What is higher rate minus lower rate? And what is the present value of lower rate? And what is the present value of higher rate? And what is the market price? So these are the variables are needed to attempt this particular problem. So here the lower rate, you can take the lower rate, the 20% and 25% can be taken for this problem. The 20% is a lower rate, 25% is a higher rate. So based on that, you know that. So here the difference is 25 minus 20. The higher rate minus lower rate is 5%, and the present value of lower rate is calculated together. The present value of interest payment plus present value of terminal value together. For the 25%, it becomes 916.15, and the present value of higher rate, it becomes 750.0648. And the market price for this particular problem, it is 900 rupees. It is given the problem is 900 rupees. So these are the values are available in the problem. Based on that, you need to work it out. So here I can write the lower rate. The lower rate for the problem is 20% plus NPV of lower rate plus NPV of higher rate. So I'll just do here. NPV of lower rate, it is you can take NPV of lower rate is, present value of lower rate, it is 916.1506 minus the market price. The market price is given in the problem is 900 divided by NPV of lower, it is 916.1506 minus NPV of higher is 750.0648. So this is a difference, and it is being multiplied with the higher rate minus lower rate. It is already available as 5% in the particular problem. So these are the values are already available. You can work it out. I'll just make some steps to understand this particular problem. 20 plus what exact? I can take, copy the same, and here I can only use the equal to, so the proportion between the two value, the lower rate minus present value of lower rate minus market price divided by the present value of lower rate minus higher rate. The proportion is 0.09 is being multiplied with the 5 is a difference. So here I'll just multiply with 5, I can get this value. The 20 is a factor, it is a lower value, can be added together. So the exact yield to maturity for the problem, it is 22.48621. It's a yield to maturity for this problem. Any of you got the result? Any of you got the result? So this is a problem. You need to work it out. If the problem is given that if a similar problem is given, you can work it out on this. So the WOETC you can take. Yield to call you can take. It is also similar to this. In spite of the terminal value, the formula itself, there is a significant difference. That's it. A very minute difference. We have the formula for calculating the yield to maturity. The present value of the coupon payment, the present value of terminal value, which is equal to the market price. Similar way, the market price is equal to coupon payment divided by 1 plus ITM to the power T plus, in spite of terminal value, here the call price is used. Here the call price is used. What is a call price? Call price, it means in the instrument is specifically mentioned, which will be called for future period of time. It means maybe called in the 5 years, maybe called in 10 years, maybe called in 15 years. If the instrument is being called at 10 years, what is the call price? If the instrument is called at 15 years, what is the price? If the instrument is called at 20 years, what is the call price? The call price is being mentioned. So here what I can do, the yield to maturity or yield to call is calculated on the basis of call price. That's the difference. Nothing else. Apart from this, all other values remains constant. Whatever the calculation you did, here it is equal to the value, equal to the yield to call, equal to the yield to call. Okay. So you know that yield to call is one option is given by the company or the issuer to the investor. You can redeem. You can the investor is going to, or like what we can say, the issuer is going to buy back of its instrument from the market, buyback of its instrument from the investor before the maturity period. So the thing is call it as call, yield to call till the maturity, till the date of call. What is the period? What is the value is realized by the investor? It can be calculated on the particular basis. Okay. So this is about yield to call.